Hey, Assalamualaikum and good day everyone. So today we are going to continue with the next lecture for topic 8, which is the 8.3 continuous random variable. So we finished with the discrete random variable last week. So for today we are going to continue with continuous. Okay, for this lesson, at the end of the lesson, students should be able to identify the probability density function. Okay, so we call it as probability density function, which is the same as probability distribution function, but we use density because it's a continuous random variable. And then the next one is to find the mean and variance for this continuous random variable. Okay, so let's see what is probability density function. So the definition, a continuous random variable is a random variable that assumes any value contained in real life interval. So previously for discrete we'll only consider a whole number like 0, 1, 2, 3 and so on. But for this continuous random variable, we consider all the value on the real number line. For example, x is a random variable for the weight of a person in a company. Okay, so we can have a weight like 67, 78, 67.5, 80.0, 80.3 and so on. And then for y, the time taken to complete an experiment. And then for z, the height of competitors in a competition. Okay, so associated with this variable are the density function. Okay, the difference with the discrete random variable, we have probability density function, which is represented as f of x, small letter of f, which is the equivalent to the probability function for the discrete case. Okay, so these functions are called probability density function PDF with the following properties. So the probability f of x should be more than or equal to 0. Okay, so the function itself must be more than or equal to 0. And then this is total probability. Okay, total probability for the PDF should be equal to 1. So this is the same as the discrete random variable. But for discrete, we need to sum all the probability. For continuous, we need to apply the integration concept. Okay, so the area under the curve of fx for the PDF should be the total area is equal to 1. And then probability of x equal to a is equal to 0. Okay, why? Because we don't have area for a certain point. Remember the properties of integration. Integrate from a to a of a function fx respect to x is equal to 0. This is the same now because we are finding the probability at a certain point only. Okay, for continuous random variable, the probability at a certain point should be equal to 0. And then the next one, probability of x less than or equal to a is the same as probability of x less than a. Okay, which is we just have to integrate from negative infinity up to a. Okay, and then lastly, probability of x in between from a to b is the same as probability of x between a to b, b inclusive, and then probability of a to b and a is inclusive, which is it's the same as integration of fx respect to x from a to b. Okay, the notation of inequality it doesn't matter with the equal sign. We have equal sign or not, it doesn't matter. Okay, so let's see some example. Show that fx equal to 3x squared from 0 to 1 exclusively. Okay, between 0 to 1 is a probability density function for a random variable x. So remember our tutorial question number 1. To show that it's a probability distribution function, we use the properties of random variable. Okay, first of all, the function is more than 0. Okay, so 3x squared is more than 0. And then we can use the second. Usually we use the second properties, which is the total probability is equal to 1. So for the continuous random variable, the total probability, we can apply the integration from negative infinity to infinity of fx respect to x, which is here we only have a function defined from 0 to 1 only, okay, which is a 3x squared. For other part, okay, we don't have any function defined on it, so it's a function 0, okay. That's why we directly integrate from 0 to 1. So actually it's integrate from in negative infinity up to 0 of 0 function, add up integration from 0 to 1 of 3x squared function respect to x, and then add up from 1 to infinity of 0 function. Okay, we can consider these two. We don't have to write down because it's a function 0. So directly for the total probability, we will be equal to integration from 0 to 1 of 3x squared respect to x. Okay, so this is the integration from infinity to negative infinity to infinity of the PDF respect to x. Okay, so integrate 3x squared, what do we get? We get x cubed over 3 multiplied by 3, which is equal to x cubed. Okay, so directly it's equal to x cubed from 0 to 1. Okay, so substitute the value 1 cube minus 0 cube is 1. So it's equal to 1, means that the total probability is equal to 1. So since the integration of 0 to 1 of 3x squared respect to x is equal to 1, fx equal to 3x squared from 0 to 1 is a probability density function. So by using this property only, we can show that whether it's a PDF or not. Okay. So next, we move to the expectation or mean of a continuous random variable. So previously, we have a formula for the discrete random variable, which is equal to summation of x multiplied by its probability, right? Okay, but now for the continuous, because we don't know what is the probability for that for all value of x, because all the value of x is on the real number line, right? So we don't have the time to calculate. We don't know specific probability for each of the value of x on the real number line. So we have this formula of expectation for the continuous random variable, which is expected value of x is equal to the integration of x multiplied by fx, the probability function, respect to x from negative infinity to infinity. You must include all the values on the real number lines that define on the PDF. Okay, and then we have the properties of the expected value, which is the expected of a function g of x. Okay, so not directly x, but a function of g of x. So it's the same as the discrete, we just have to multiply the gx with the probability function. So we have gx multiplied by fx, and then we integrate it from negative infinity up to infinity respect to x. Okay, then for question number 3, expectation of ax plus b. Okay, first of all, it's actually just the integration of ax plus b multiplied by the probability function, right? From negative infinity to infinity. Okay, but we also can apply the same properties for the discrete, which is expectation of ax plus b can be defined as a multiplied by expectation of x plus b. Okay, why? This is by using the definition of expectation. So we can separate this, by the properties of integration. Okay, we can separate this into integration of ax multiplied by fx from negative infinity to infinity respect to x, plus the integration of negative infinity to infinity of b multiplied by fx respect to x. Okay, so if we factorize out the a here, we can factorize out the a as a constant. So integration left here is negative infinity to infinity of x fx respect to x, and then
we can also factorize out the b. So integration b multiplied by integration of fx respect to x from negative infinity to infinity. Okay, so this part on the left side, integration of fx respect to x from negative infinity to infinity is the total probability of the PDF, which is equal to 1. And then here is the expectation of x, the formula for the expected value for the continuous random variable. That's why it can be represented also as a multiplied by expected of x plus b. Okay, because b multiplied by 1 is b. Okay, so these properties we can use to solve for the expectation for the continuous random variable. Okay, so let's say example 2. So the random variable of x has probability density function. So we have fx, this is a brace bracket. So if you have brace bracket, means that is a, yes, we have a piecewise function. So it's represented as a multiplied by x minus x cubed when x from 0 to 1, and then 0 for otherwise, means that other than 0 to 1 we don't have any function, or the function is 0. Okay, so other than 0 1 the function is 0, so we only have the function defined on 0 to 1, which is a multiplied by x minus x cubed. So to show that a equal to 4, what we can do is to apply the properties of the random variable, which is the second one. The total probability must be equal to 1. Okay. So we integrate from negative infinity to infinity of the PDF respect to x. So since we have only function a multiplied by x minus x cubed defined on 0 to 1, so we integrate only from 0 to 1 of a multiplied by x minus x cubed respect to x equal to 1. Now, after we integrate, what do we get? A is a constant, so we just need to integrate x minus x cubed, which is equal to x squared over 2 minus x to the power of 4 over 4. And then substitute the value from 0 to 1. So we have 1 over 2 minus 1 over 4 minus 0 and multiply by a, which is equal to 1 over 4a equal to 1. So a is equal to 4. Right? So this part we get 1 over 4. So 1 over 4a equal to 1. So a is equal to 4. So we have shown that a is indeed equal to 4. So for question B, they ask you to find the expectation. So apply the formula because we have a PDF defined on 0 to 1. So just integrate from 0 to 1 and multiply the PDF with x. So x multiplied by the PDF, 4 multiplied by x minus x cubed respect to x. So we can factorize out 4 first. Okay, apply the properties of integration. 4 integrate, or you can expand directly. If we factorize out 4, what's left inside the bracket is just x squared minus x to the power of 4. So we just need to integrate x squared minus x to the power of 4 from 0 to 1. Okay, but now if we just expand the formula, the function, what do we get is 4x squared minus 4x power of 4 respect to x. So integrate this term, we have 4x cubed over 4 minus 4x power of 5 over 5 from 0 to 1 and substitute the value, we get 4 over 3 minus 4 over 5 and then minus with 0. So the answer here is 8 over 15. So this is the expected value of the continuous random variable.
Okay, now for variance of continuous random variable function. Okay, so we know the formula of variance is a sigma square. Okay, from the data description. And then we also know for the discrete random variable, variance of x is equivalent to expectation of x square and then subtract by the expected value square. Okay, so this is the formula, the same formula from the discrete random variable. So for the continuous random variable, we also use the same formula. So but the way we are finding the expected value is different. Okay, so we just have to apply the properties of expected values to get the variance. Okay, so if a is a constant, so this is the properties of variance, we have a variance of constant A is equal to 0. So this is the same as the discrete random variable. And then the variance of ax squared will be the same as a squared multiplied by variance x, which is the same properties for the discrete random variable. Right? Okay, so we just have to use these two properties now. And then for variance of ax plus b, it will be a squared multiplied by variance of x, which is the same as the discrete random variable. So for the properties, we don't have to worry now, because it will be the same for the continuous and discrete random variable. Okay, let's see some example. So example 3, we have here the continuous random variable x has probability density function. Okay, so it's a continuous random variable, right? Where fx is equal to 1 over 20 of x plus 3 for x from 0 to 4. And then 0 function for other ones. So now we want to find expected value of x and then expected of w. So where w is equal to 2x plus 5. And then expected of x squared. And then variance of x, and lastly variance of 3x plus 2. So let's see how do we find for the expected value of x. Okay, so what is the formula for the expected value for the continuous random variable? Okay, we just have to integrate the total probability multiplied by its x, probability function multiplied by its x. So expected of x should be integration of x multiplied by its probability function, which is 1 over 20 of x plus 3 respect to x from 0 to 4. And then what do we need to do is to expand, and then we factorize out the constant, or you can just expand. So if we want to keep the 1 over 20, just put there and then just expand the part for x and x plus 3. So we have x squared plus 3x respect to x, where we need to integrate. So for 1 over 20, we factorize out as a constant. So integrate the x squared plus 3x, we get x cubed over 3. And then plus with 3x squared over 2 from 0 to 4. And then substitute the value, we have 4 cubed over 3 plus 3 multiplied by 4 squared over 2. And then minus with 0. And don't forget to multiply with 1 over 20. So what do we get as a result? It's 64 over 3 plus 3 multiplied by 16 over 2. So we have 34 over 15. The answer for the expected value is 34 over 15. And now we move on for the next question. B. They ask you to find expected of w, where w is equal to 2x plus 5. Means that we need to find the expected of 2x plus 5. So what we can do, we can apply the properties of expected value, which is this is equivalent to 2 expected of x plus 5. Okay. So, what is expected of x? We found out already on part A. So, substitute the value of expected of x, 2 multiplied by 34 over 15 plus 5, which is equal to 143 over 15. So, you don't have to integrate again. Now, we have saved some times. Okay, we don't have to integrate, because integration is the concept is a bit trickier, right? We might do some careless mistakes. So just apply the properties here. Okay, now for question C, we need to find the expected of x squared. So now the difference here is that the value of x should be x squared. It's not only x but x squared. We multiply by with the PDF, which is 1 over 20 of x plus 3. So now we can factorize out the constant 1 over 20 and then expand the x squared with the x plus 3. So we get x cubed plus 3x squared. Then integrate it, we get x power 4 over 4 plus 3x cubed over 3, which is equal to x cubed only. From 0 to 4, we need to substitute the value. So we get 4 to the power 4 over 4 plus 4 cubed and then minus with 0. So the expected of x squared, the final answer, use your calculator, we get 32 over 5. So we are done with question C. Now we continue with question D. They ask you for the variance. Okay, what is the formula for variance? So we know the formula for variance is expected of x squared minus expected value squared. Okay, so expected of x squared we find out already on question C, which is equal to 32 over 5. And then expected of x we know already from question A, which is equal to 34 over 15. So it will be 32 over 5 minus 34 over 15 all square. Okay, we square the value of 34 over 15, the expected value here. Okay, use your calculator, directly we get the answer 284 over 225. Okay, lastly for question E, they ask you to find the variance of 3x plus 2. So we don't have to apply the expectation formula and so on. Directly apply the properties of variance, which is this is equivalent to, yes, factorize out the coefficient of x, which is 3, and then square it. So we get 3 squared variance x. So we know already the value of variance x from part B. So substitute the values only. So 9 multiplied by 284 over 225, which is equal to 284 over 25. Okay, so you don't have to do the integration repeatedly. Just for the expected of x and expected of x squared. Other than that, we just use the properties. Okay, so that's all for this lecture 3. We continue with lecture 4 later. Okay, thank you. You guys can try tutorial 3 already, yeah? Okay.